Hello everyone and welcome to another episode of Project Euler 100, in which we're going over the problems in the Project Euler series. I think we should call it series, right? So far we did problems from 1 to 23 and 25. Last time we had some issues figuring out how to solve problem 24, which was a bummer, but well, I've looked up some resources and hopefully today we can solve that and move on to the next one. Hello Lauren and welcome. Whoops, I have the wrong overlay there. Good. I did have the wrong one last time too. Alright, if you are in the chat, if you support the freeCodeCamp community and become a member on YouTube, then you will be able to chat and help me figure out the solutions here, because some of them will be pretty tough. I've looked at the next one, the 26, and they're not getting easier, that I could tell. I don't know how long we will be able to go. They're getting very math heavy, so yeah, we'll see though. Now, for the problem 24, let's go over again what we had to do and then eventually solve it. Hopefully this time we can. Lexicographic permutations. This is a hard word to pronounce. A permutation is an ordered arrangement of objects. For example, 3, 1, 2, 4 is one possible permutation of the digits 1, 2, 3, and 4. If all of the permutations are listed numerically or alphabetically, we call it lexicographic order. The lexicographic permutations of 0, 1, and 2 are these, right? You can see they go in order. And what we have to do, we need to see what is the nth lexicographic permutation of the digits 0, 1, 2, 3, 4 up to 9. So for that, I think we need to get all the permutations in order and that get the nth one, right? Okay, now last time we looked at one algorithm, which, well, it's pretty much the same algorithm we have here. I found this on Quora thanks to Daniel Schiffman. He solved this using this algorithm. So I took a peek and I think I know now how to do it. So basically we have 4 steps. Let's first create that array, which will be the, let's see, so we could have an array of arrays, or we could have an array of strings. I'm thinking which one should be better. Let's start with an array of arrays. So maybe, let's see, permutations. And the first one will be 0, 1, 2, 3. Let's start with the smaller one and see that we have it correct. And afterwards, yeah, I don't like this for some reason. An array of, let's start with, oops, I ran it. Maybe have initial and let's have it as a string. I'm thinking this should work. Okay, let's look at the algorithm now. So it's all about the indexes inside that array. As you can see here, we have an array of arrays. So inside this array, we have indexes, index 0, 1, 2. Now, they are the same as the numbers we have in the array, but they will change. So look at what this says. Find the largest x such that p of x is less than p of x plus 1. If there are no such x, then p is the last permutation. So we go inside the array and we go over all of them up to the last one and we check, is this index p of x, is this number let's see, less than the next one. If it is, then we save the index and we go that way. Does it make sense? I guess it will do when we write the code. Then the next step will be to find the largest y, so the index, such that p of x is less than p of y. Then we swap the two elements inside the array, and then we reverse from p of x plus 1 up to the end of the array. So let's copy this and have it here so we don't change the tab that much. So this is 1, then this is 2, this is 3, and this is 4. Okay, so let's do that. What we want to do, should we have the array initially, then push it somewhere? I'm thinking. Okay, or we could go over the string. Yeah, let's start with initial to be a string actually. 0, 1, 2, and then permutations. And we can even put them inside the function here. Okay. Yeah, I didn't check. Can you hear me well? Can you see everything well? Hopefully. Okay, so we don't have any permutations. Now, let's see. How long do we want to do this? This is the thing which will stop it, right? So we could do a while. Yeah, we can do a while. Now, freeCodeCamp platform will complain about this. I think we can even find out how many permutations there might be, and we can just loop until we have all the permutations. That could be one solution to avoid while true. But yeah, let's look for this now. Okay, so 1. Find the largest x such that p of x less than p of x plus 1. So for that we need a loop, I be 0, I less than initial, this will be changed. Yeah, so let's call it current or array, because we're going to work on this array and we're going to swap elements inside it, and then we're going to push them here. I guess we can put the first one, and then we're going to push the next ones. All right, let's see how this goes. So array.length -1. So we don't want to go up to this. So we want to check this with this, and then this one with the last one. I++. If, so we have here, find the largest x such that p of x less than p of x plus 1. If array of I is less than array of I plus 1, then we want to store this index. So let's call it, let's call it x and be -1 by default, as if we don't find it, we will break out of the loop. That's the base condition. If there is no such x, then p is the last permutation. Okay, and here, so if we find this, then x will be y, right? So it will be the current. Let's see, so find the largest x such that, yeah, so we need that. Now this is the base, so let's call it the break condition. Step 1, or let's just put 1 here. This will be the break. So if x is -1, so we don't find here, then we just want to break out of the while loop. All right. If not, then we want to go to the step 2. And here we need to find the largest y such that p of x less than p of y. So again, we need y, which will be -1, for let I is less than 0, I is 0, I less than array.length, I plus plus. We can go up to the end of the array now. So now, if array of I is less than array of y, then we want to store that, right? Yeah. So y will be I. Let's see. So x is y. Yeah. Well, x is I, y is I. Good. Good. So that should be doing that part. And let me put this up here. And for the next one, we want for 3, we want to swap the two elements. Now, swapping elements, for that, if we swap the elements inside this array, well, first it's a const, so we can't really manipulate this array. So for that, let's create a new array. So let new array, which will be a copy of the old array, right? So we copy, everything is inside here. Okay, now issue is that we still need this new array in the next loop. So let's just work with this one then. We're going to change this array on here. Okay, so we want to swap two elements. How we're going to swap? We need a temporary variable to store one of the items. So maybe array index x. Then array index x will be array index y, and array index y will be temp, right? So we store array index x in the temp, and we use it then later. We swap the two elements here. Swap. Yeah, let me write something here. Find largest x, largest x, and next one is find largest y. Find largest y. Okay, and then we swap, and at the end we want to reverse this array from x plus 1 up to the end. So how we're going to do that? Reverse. Array, let's see. So we go up to that element, we keep it like that. Then we take the rest of the array and we reverse it and put it back, right? So array will be array slice from 0 to x, and we want to add to this, so concat, or we could do something like, well, spread it inside this new array, dot slice x plus 1 and reverse. So we take the first half, we add it inside the new array, and then the second half from x plus 1 we reverse, and then we add it in this array. And now hopefully, if we did it right, let's add it to the permutations array. So permutations that push the array, which will basically be the new array in the loop. And let's just return the permutations here so we can see them if we console.log. All right, let's see. 0 undefined, 2 -1 1. Okay, that's not good. What's happening here? So permutations, and then we push the array. Is this something? console.log permutations. Okay, that's good. I think we're messing with the array and it doesn't like it. Array of x. Yeah, but then oh. So when we put here the array and then we change the array, it will also change its place inside this array. So let's then do something else. Let's just join this array, have a string, and whenever we push, we just join again. Alright, that's a start. You can see that we kind of have the pattern, we just missed something. Let's see, so slice from 0 to x. Alright, and slice from x plus 1. And then reverse. Let's see these two values so we can see exactly what's happening. So this, and then console.log this. And yeah, obviously that's not to that. I'll put this here actually. So 0, 2. Oops. Let's see that. 0 and 2. That's not what we want. X minus 1. No. So in this instance, I think, so we want to swap these two. And they shouldn't. This shouldn't be reversed because it's the last one. Let's see, do we have here an example? Suppose P is this number, diagram proceeds as follows. Starting at the end, we see 4 greater than 2, then 8 greater than 4, then 9 greater than 8, and finally 3 less than 9. Hence our x is 5. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. Why is 5? 0, 1. Oh, 1, 2, 3, 4, 5. It's 1. It's not 0 based. Probably that's why. Okay. Then starting from x plus 1, we can see that 3 less than 9, 3 less than 8, 3 less than 4, but 3 greater than 2. The last value that was still greater than 3 was 4, and its index was I8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's 1. The first slice would just reverse nothing because 1 item, right? Yeah, and we want that. If it's 1 item, it shouldn't be reversed. Okay, by swapping POI we obtain, so we should swap 3 with 4. Yeah, that's what it does. 4, 3. Okay, by reversing the part from x plus 1 to the end, we obtain a result of the permutation. So it should swap these. Yeah. So I got right the logic. So this was x, and we need to swap all these. Now maybe the slice does here something we don't want. Undefined, undefined. First half, second half. 0, 2, undefined. All right, so something's going on there. We have undefined, at least now we have the correct length, I guess. Console.log, let's see the array. We have an undefined there, which is not good. 0 undefined, 2 minus 1, 1. What is this? Let's break after one loop. That's definitely not what we want. So x is minus 1, we go from 1 up to, from 0 up to array dynamic minus 1. And that's that. Let's see console.log x. Bugging here. X is 1. Okay, good. Now y should be 2. So let's see console.log y. This should be 2. Alright, that works. Now the swap. The swap is maybe doing something tricky here. Array of x, array console.log temporary. Okay, temporary is 1, array of 1. Yeah, good. Then console.log array of x. Array of x is undefined. Why? Array of y is 1. Okay, gets from temp. But why it's array of x undefined? Array of x 1, and then afterwards it's undefined. Why? What's array of y? Okay, array of y. Array of y is undefined. Console.log array of y. Array of y. I think here is undefined too, but why? Y is 2. Y is minus 1. Okay, okay, okay. Oh, I think I know. You did console log y 2. Oh. I did. I console log the value should be. That's why I didn't see. Alright, so it's minus 1. So here we have an issue. Let's go with the loop. So find the largest y such that p of x less than p of y. So p of x. Yeah, so if p of x less than array of I, then that's alright, good. So that was the case. We used the wrong indexes here. My bad. So now it should let me remove all these consoles. Oops. Good. Maybe the slice now it's wrong. We should have, let's see, console.log array here. Should be the correct. Yeah, good. Good, 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 good. If we remove the break, goody goody, almost. So then this breaks somewhere. Console.log array again. All right, so 0, 1. Let me see this again, what I'm doing here. Slice and the reverse and everything. And let's see this before we actually do it. So many console logs. Please break here. So this is the array. This is slice 0x. 0x should be that included. 02, and then the end should be that. Okay, so that's the slice goes up to but not included. So then we go from 0 to x plus 1, which is not included, so gets only up to x, and then from x plus 1 we go up to the end. If you don't specify the second one, then it goes to the end. Okay, so now this should work. Let me remove the console logs here. We still have one console log here and one here. Oh, that works. All right, finally. After years of work, a week, we got it. So now it should work with 0, 1, 2, 3. Should work with 0, 1, 2, 3, 4. Finally, thank you. Let's see who wrote this. Although, so we saw this algorithm last time, but I didn't know exactly how to take it. Thank you, Michael. And thank you, Daniel Schiffman, for explaining it much better. Oh, he kind of did the thing I'm doing. Failed a bunch of times. And then eventually he got it right. All right, good. So this is it. Now what we want to do is to put 5, 6, 7, 8, 9. Let's not console log, so let's not return the permutations, but rather permutations. All right, that will break. Let me remove this. It's long, so it might break. Yeah, so permutations of n, right? We are given the n and we want that. Although we can do one thing. When the permutations has the length n, then we can stop. Let's see, will this work properly? Undefined. That's one way. Permutations are nice. Yeah. Let's see, will this be too much? Test timed out. Oops. Test timed out. If this doesn't work, then, well, I mean, it should work, we just need more time. It is an n factorial, or it's just n. Yeah, so this, let's just do if permutations that length is equals to n, right? Then we just do permutations of n. Oh, if, then break. They should be faster. It doesn't go up to the end. Should return number, should return. Oh, I think it works. We just return now a string because we have an array of strings, not a number. Okay, I won't argue. Should return. Well, at least we got a number, so something is still wrong here. All right, let's do what we did last time and run this on directly in VS Code so that we can see exactly what's happening, although it will take some time. So permutations. Let's open this with VS Code. The browser might be, and their thingy might fail, although it might time out. Okay, permutations. I'll just script the JS. Paste this in, and yeah, permutations of n. Oh, equals n plus 1, because we want permutations of n, and the permutations of n will be undefined, right? Because it's 0 based. So here up to n plus 1. No. Let's see what's happening. We want to see, yeah, that we need to return the number, and for 99999 we should get it. Oh yeah, so it worked. All right, I didn't have to run it again. That was the issue. So we wanted permutations of n, but we only went up to permutations n minus 1 because it's 0 based. All right, good. I won't try again. We could put the link here from Quora in case someone wants to take a peek. Okay, run the tests again. It's slow, but eventually it works. We don't need this anymore, so we can close it. All right, so this has some issues. Download the code. Yeah, that's what I want. Once it works. Now it might time out sometimes, depending on... yeah, let's save this quickly. Submit and bye. Go to the next one. Okay, so we did this. David, thank you in the name of freeCodeCamp for becoming a supporter. Now you can join the chat and help us solve this. We finished 25% of 100. I honestly don't know how far I could personally go because they're getting math heavy. Really math heavy. You'll see the next one. I took a look and I like this argument, but it seems expensive. Yeah. All right, so water break. Yeah, look at this. I can't even read it. This is another math heavy one. What I'm going to do from now on is if I get stuck for a long time, I'm just going to go to the next one. Maybe we can solve it. I don't know if you were in the previous stream, but this is what happened. So we worked like an hour for this one. We couldn't do it. And then we solved this in like 5 minutes. So yeah, we might skip a few. If we don't know, we can research and find up ways to do it. And we can come back later and solve it. Or yeah, I honestly don't know if I can finish all the 100 project. If I can, then we're going to do something simpler, maybe Code Wars or other coding challenges. Depends on what you want. So yeah, feel free to let me know. Okay, problem 26, reciprocal cycles. Hopefully I pronounced this right. A unit fraction contains 1 in the numerator. The decimal representation of the unit fractions with denominators 2 to 10 are given. So these. When you divide 1 to 2, you get that. What's up, I'll become a member just for you. Oh, thank you. You're great. Yeah, we're solving these challenges, or at least we're trying. How are you? Okay, so we get all of this. Now the parentheses means that that number will repeat at infinite. So yeah, it's a recurring cycle. It can be seen as 1 over 7 has a 6-digit recurring cycle. This one. Now, what we need to do, and I honestly don't think I know. I don't think I know. I don't know exactly. Find the value of d less than n. So we get an n here. We need to go over all the numbers for which 1 over d contains the longest recurring cycle in its decimal fraction part. So in this case, the longest recurring cycle is 1 over 7, right? Because it has 6 digits. Yeah, it looks quite like fun, although how we're going to do this? So basically we need to do the division 1 over d while going over the numbers. So let's do that. Let I will be 2, I less than n, I plus plus. And here we need to do the division. So result will be 1 over I, or I guess let's call it d. So then it will be easier to see. So d, we start with 2 and we go over that, we get the result. Hey Arpan, welcome. So we get the result, and now we should look inside the digits and see how many of recurring digits we have. Any ideas in the chat? Lauren? David? Arpan? Anyone? Let's get the result. Let's see what we have here. All right, so we get something like this, which we might be able to use or not. How we're going to find out? Split the result into an array and then array that length. I don't know. Use the modulus and the long division. So I keep dividing, but then how do we know we have a cycle? So here we go 3, then we see 0, then we see 3 again. We can kind of check this 3 again. So this is the thing. How can we find out when we have a recurring cycle? Look at this, 285714, 285714. You can kind of see visually, but for something like this, when you get the same number again, then the division will give the same result, so they cannot repeat. Okay, so something, I see something there. Now again, look at this. Here we have the, I don't know, the 5th index, we have that 3 which will repeat. I don't know. What about this? Where it will repeat? We might end up in an infinite loop. We can't find something to be repeated. You can see this is repeating. 1785, 714285, 857142, 857142. So this starts here. Yeah, I don't know. 666 over and over. Yeah, I don't know exactly. How can we find out? We can kind of get the digits, and maybe using division we get it. Hmm. Yeah, I don't know. Maybe we should research this and then come back later. Yeah. Let's see what about the next one. 26. Oh, this is 26. If you do the long division, you multiply by 10 and that is your new numerator. Yeah, but we need to multiply by the length of the number. So if we have 5, 6, 7, then we multiply, so we get 1,000. We divide it in 1,000, and yeah, too mathy. Let's go to the next one. Quadratic primes. This doesn't look well either. If the numerator repeats, then you are in a loop. Yeah, but when do you know it repeats? Oh. Quadratic primes. Euler discovered the remarkable quadratic formula. N squared plus n plus 41. It turns out that the formula will produce 40 primes for the consecutive integer values between 0 and 39. However, when n is 40, is divisible by 41, and certain when... Yeah, okay. So that doesn't work. The incredible formula was discovered, which produces 80 primes for the consecutive values. The product of the coefficients, minus 79, and that, yeah, so mathy. Consider quadratics of the form n squared plus an plus b, where modulus of n less than range and b less than... I bet Euler will be terrible at parties. Who knows? Depends on the party. It might be a coding party, so then he will be a genius. Or a math party. And mod is modulus, yeah, good. Find the product of the coefficients a and b for the quadratic expression that produces the maximum number of primes for consecutive values of n, starting with n equals 0. Oh boy. This is not easy again. 1 second. Okay. Numeric spiral diagonals. Starting with the number 1 and moving to the right. Okay, 1, 2, 3. So we kind of did something like this. What is the sum of the numbers of the diagonals? Oh, so this should be doable. Finally. Finally something doable. What I see here is actually not that bad. So you can see there's a pattern. So from in the inner circle, we get 1, 3, 5, 7, 9. Then we get plus 4, plus 4, plus 4, plus 4. They are all doable, yeah. But not by me. Spirit, whoa, so what is the sum of the numbers on the diagonals in an n by n spiral formed in the same way? N by n. What? Till 100. I don't know. Whoa, so yeah, we definitely won't have to draw the, well, how do you call it? The matrix? This took you 2 days? Did you reach this far? You did all of them? Oh, that's pretty good if you did. Then teach me. Yeah. So I kind of see a pattern. Starts with 1, the next one are 2 bigger, the next one are 4 bigger, the next ones are probably 6 bigger. So for that I want to just write it. 21, 22, 23, 24, 25. You got that one. The one you mentioned, 07, 08, 09, 10, 19, 6, 1, 2, 11, 18, 5, 4, 3, 12, whoa, 18, 17, 16, 15, 14, 13. Okay, so what's next? Like that. Okay, so here we go, 26, 27, 28, 29, 30. Let me put some boilerplates here. 31, 32, 33, 34. I just want to write them down so that we can probably find a pattern. 38, 39, 40. I mean visually, and then we can kind of create some kind of formula. 42, 43, 44, 45, 46, 7, 8, and 9. One thing you can notice that they're all odd numbers. Okay, so as I said, these ones are like plus 2, plus 2, plus 2, plus 2. Then plus 4, plus 4, plus 4, plus 4. And if I'm right, hopefully, the next one should be plus 6. Yeah, 25 plus 6 plus 6 plus 6 plus 6. All right, so then this is not that hard. We start with 1. We add 2 4 times. We add 4 then, and we just increase the number we're adding by 2. See? Yeah, that should be. I don't understand why this is so easy and then the previous one was so hard, but maybe for some people it's the other way around. All right, so let's sum will be 1. Let add, addition. This will be the number we want to add. And for, let's see, let I 0, I less than n, I plus plus. So if n is 1, we don't add. N is 1, we have 1. We start with, sorry, I is 0. We don't want to do that. With n is, wait, I'm losing my train of thoughts now. So if n is 1, yeah, okay, good. Now if n is 2, we want to start doing this sum plus equals add like that. And we want to do it 4 times. Well, I guess we could do j equals 0, j less than 4, j plus plus. And we do that. And here at the end, we just do add plus equals 2. And return the sum. Fingers crossed. Console.log. That doesn't seem to work. What is the sum of the numbers on the diagonals? So what happened? What did I miss? Let's see. So for 101, oh, so the sum is not that number, it's the sum plus the addition. So we start with 1 and then we add 1 plus, so sum will be, okay, let me think again. So the next number will be 3. So we increase the sum. Oh, okay. Let's keep track of the current number. Number will be 1, the sum will be number, and here the number will be plus equals add, and then the sum will be plus equals num. Pretty close. Add, so num it's 1, then it's 3, then it's 5, 7, and 9, right? Let's check console.log. Well, first let me just do this so we don't get a lot. Console.log num. Okay, if we do for 3, we get 3, 5, 7, 9, 25. 25. But why? It's 4. Oh, okay. 25 is the, okay. It's just the return of the sum here. So the sum is that. All right. So now, yeah, my bad. So the next numbers, let's see. 3, 5, 7, 9, 13, 17, 21, 25. The next ones will be 31, 37, 43, 49. So it works. Should start from 1. No, this apparently works. Maybe I just don't need to go up to n. Okay, so it can be verified that the sum of the numbers on the diagonals is 101. Yeah, so we have n equals 3. Okay, for 4 will be 1. Yeah. Okay, so we need to go up to n plus 1, or n inclusive. And now if we do 3 here, we should get 101. Yeah, so I was going 1 less than we should have. So now this should work. We don't need to console this. We get 101. For 101, we should get that number. Let's run. Yeah, so no. Apparently we're failing. What is the sum of the numbers and diagonals in an n and n spiral formed? Wait a second. Starting with the number 1 and moving to the right in a clockwise direction, 5 by 5 spiral is formed. But we're not then. Maybe missing the last round. Yeah, it was initially, but wait. So this is not 3 by 3, this is 5 by 5. So we're missing here the ends. Because for an n of length 5 by 5, we get this big number, but actually we should only get 101. So maybe -1. Yeah, it will work now. With 4, you get 10, you get that, which is a 3 by 3. So this doesn't feel like being right. We're going way further. What about n divided by 2 plus 1? I really don't know. Don't ask me why. I don't know. But anyway, okay. Yeah, it works. If n is 3 and you start with I equals 2, then you have only one loop. Yeah. You know, there are two questions a programmer is asking. It doesn't work. Why? And then the second one is it works. Why? So yeah, I figured something somewhere. So basically here we have a 5 by 5, but we only increase 1 2 times, right? Yeah. See, so we have a 5 by 5 grid, but this goes 1 and 2. So then we have 5 divided by 2, which is 2.5, plus 1 is 3.5. So we go twice, because we have one in the I is 2, and then it goes for I is 3. Yeah, the reason why I used divided by 2 in my mind, I think, so I noticed that it's kind of half. So I did divided by 2, and then I saw that this number is just a bit smaller than this one. And then, oh well, why not plus 1? And that worked. Yeah. Oh well. Life of a programmer. Yeah. Let's download it. This is one of a kind. Let's go to the next one. There are so many numbers here again. Let's see. Consider distinct powers. Consider all integers combination of a, b, 4. 2 less than equals a, less than equals 5. So a between 2 and 5, b between 2 and 5. This to the power of 2, power 3, power 4, 5. If they are then sorry. So if they are then placed in numerical order with any repeats removed, we get the following sequence of 15 distinct terms. How many distinct terms are in a sequence generated by a to the power of b for 2 less than, so a between 2 and n, b between 2 and n. Okay. So basically we go over this loop twice. So from I, or we could use a from 2 to n, b from 2 to n, we get a to the power of b, we get the numbers, and then we remove the duplicates, and we check how many distinct numbers there are. Right? I think. So let's use a this time. 2, a less than equals than n, a plus plus, for let b equals to b less equals than and b plus plus, and then we need to do and the result will be met.pow a to the power of b I'm thinking now we need to put them in an array. We could do const array like that and do array.push result, and then, well, we need to filter out the duplicates, but let's see what we get here. Console.log that. We get all these numbers. Look at that. Cool. So many numbers. But we want not duplicate numbers, so we could convert this to an object and do object of res to be true, and then here we have object which will have all the values and they will be unique, so we can just do object.keys of object.length. That works. All right. So we have all the distinct numbers. We put them in this object, and at the end we get the keys, the length of the keys. All right, good. This wasn't that hard. And thinking to the ones we skipped. I don't like that we skipped them, but they were so easy. They're so hard. This was easy. Yeah, by the way, if you're watching and did you enjoy what you're seeing and you want to support freeCodeCamp, if you learned on freeCodeCamp, feel free to donate, support the nonprofit organization, and help others learn how to code for free. All right, digit and powers. Surprisingly, there are only 3 numbers that can be written as the sum of 4 powers of their digit. Oh, that's interesting. So if you get a digit to the power of 4, you get that. As 1 over 4 is not a sum, it is, oh, it's not a sum, so it's not included. All right. The sum of these numbers is that. Okay, find the sum of all the numbers that can be written as the sum of n powers of their digits. What? This, so all the numbers. I mean, what's the limit? All the numbers, like a gazillion? Do we need to go up to a gazillion? How do we check for that? What's the stop, the breaking point? I mean, you can see that at the power of 4 you can go up to 9,000. Any idea? So we could simply just, well, take a number, break the digits, raise them to the power of n, and do the sum. So that's easy. But then what's the stop? So where do we stop? How many numbers do we check? There must be a way. So how do we know that this is the last number? There are only 3 numbers that can be written as the sum of 4 powers of their digits. The sum of these numbers is that. Find the sum of all the numbers that can be written as the sum of n powers of their digits. If they would say, like, find the sum of all the numbers from up to n that can be written, then that would have been, yeah, easy. But yeah. See, so one is too easy, the next one is not too easy. I have no idea where to look, what to think to be the stop condition. I mean, do I go up to 10,000? Do I go up to 100,000? How can we find out that there are no more? I mean, yeah, this is surprising that it's only 3, because after 9 here you can go 1 0 and something, but yeah, apparently there are only 3. I'll trust them. But how do they know? Did they check like all the numbers in the universe? uh, no idea. Honestly, I don't have any idea how to do that. I mean, only for passing the test, I can kind of see that this goes up to probably 100,000, because we have a sum of numbers which go up to, which will result in 443,000, right? But that won't be a good solution. Maybe brute force first. Yeah, and have a brute stop. So we have 0, look at this. We have 0 numbers which their digit to the power of 2 equal the number. 0 numbers. So then basically when you finish the available numbers, yeah, that will time out. Thank you for becoming a supporter. In the name of freeCodeCamp, thank you very much for supporting the channel and the non-profit organization. Yeah, let's go to the next one. At the end, we're going to have like a lot of empty spots here. Coin sums. This looks like a fun thing. Coin sums. In England, the currency is made up of pound and pence, and there are 8 coins in general circulation. 1 pence, 2 pence. Isn't pennies? I don't know. England coins. All right. It is possible to make $2 in the following way. 1 pound, 1 times 50 pence. All right. How many different ways can n pence be made using any number of coins? Does this feel like permutations again? How many different ways? This is definitely an algorithm somewhere. Like, I mean, you can do, okay, first you can do it by having, so n is 50, right? You can do it by having 50 pence. I don't know how to pronounce that, sorry. And then you can do it by having 48 of 1 and 1 of 2. Then you can have it 46 of 1 and 2 of 2. See where I'm going with this? Then you can have it 45 of 1 and 1 of 5. So that's a gazillion. This is definitely an algorithm. And unfortunately I don't know it, so I won't spend a lot of time to try to get it because I'd have no idea. These are getting harder and harder, so I don't know. I could start to learn about algorithms more in depth, but then I need to learn them in a way so that I could teach it. Yeah, it's becoming complicated. Or we could switch. We can put Project Euler on pause. It's very math heavy. This is why it's getting harder. But I guess that's the idea. Pen-digital products. We shall say that an n-digit number is pen-digital if it makes use of all the digits 1 to n exactly once. For example, the 5-digit number 15234 is 1 through 5 pen-digital. The product 7254 is unusual, as the identity 39 times 186 equals the number contains oh boy, so fancy words containing multiplicand multiplied, and the product is 1 through 9, so you basically have all the numbers. Okay, find the sum of all products whose these things can be written as 1 through 9 pen-digital. Hint: some products can be obtained in more than one way, so be sure to only include it once in your sum. Okay. Yeah. We kind of hit a end here. Laurent, what do you think? Are they getting harder and harder? So we can go over the numbers and find the products. Find the sum of all products whose multiplicand multiplier product identity can be written as 1 through 9. Yeah, we have it here, so we can just return that and we pass. Don't do this. This is just for fun. Don't do this. You should solve it. Google, let's learn together. I mean, I don't even know where to start. Basically, we can get a number which doesn't have similar digits, and then get two more numbers. All of those digits should be available from 1 to 9, and then somehow the multiplication of those numbers should end up to the third number. All right, I don't know. Keep trying. Is this all we could do? Digit cancelling fraction, digit factorials, circular primes, double base palindromes, truncatable primes. Numbers, numbers, numbers. Powers, primes. Was it the same at the beginning? Number, yeah. Kind of was with numbers. But it was like simple. 32 is hard. Yeah. Aren't they all? Everything's hard if you don't know what to do. Let's see the next one. Fractions. Again, we need to find out everything. Exactly 4 non-trivial examples. Okay, I think I hit my end here. Digit factorials. 1, 4, 5 is a curious number, as 1 factorial, 5, 4 factorial, 5 factorial is the number. Find the numbers and the sum of the numbers which are equal to the sum of the factorial of their digits. Find the numbers and the sum of the numbers which are equal to the sum of the factorial of the digits. So again, going over all the numbers, I mean, we can see here that we have only two numbers, two curious numbers. But then I could just do it like go up to 100,000, right? Do that, find the factorials. Let me check something. Project Euler .net. I want to see what they want in this what's the requirements for, where is it? 34. Find the sum of sorry, find the sum of all numbers which are equal to the sum of the factorial of their digit. Again, the same problem which we had before. Yeah. All right. I think I'm going to stop here, unfortunately. And yeah, I don't want to keep you all here to see me not know how to do this. And I'm going to look all of them, see if we could solve them or other problems. And if not, we're going to start another series. Yeah. They are getting harder, but oh well. We did 27, so that's a start. Someone with more knowledge of algorithms should be able to do more, so I encourage you to try, and you can rub it on my nose. I think that's a saying, right? And yeah. All right. Yeah, see you in the Discord. Thank you for joining. Sorry for, yeah, I don't want to just keep you here watching me fail that hard. I mean, you won't learn much, so I will look at them, and when I found solutions the way I could probably explain, we're going to get back and continue this. Thank you for watching. Thank you for being part. I think this was the 5th or the 6th. So we had a good run. Maybe one day we can continue. But we need to learn. So let's do that, and I'll see you the next time. Bye.